That's where we were. Oh, so we were doing this one. Ah, yes. Okay. Yes, now tree diagrams. Okay, what goes where?
So does the 5 hard ones go just below the 4 at the start?
Yeah.
Okay. Choose one, put um hmm. I can't find the information for the other bits for the first and second choice.
So she chooses a toy at random and then
Okay.
puts it back. And so,
Okay.
what do you know about these then?
Does that mean it has to be half? So it'd be 50-50.
No. She takes a toy out but then puts it back.
I'm confused.
So if she takes a toy and then puts it back, basically it's going to be the same.
Okay.
Nothing's changed because she put it back.
Okay.
Yeah. Oops. So they've... That's a frequency tree, so they recently changed them, and so I'm just doing it their way. So how about this one?
So she has so she has 7 yellow balls and 4 red balls, so that would be the main parts. Jenny takes one of the balls, one of the ball from the bag, and replaces it, and then takes the second ball from the bag. Oh, I'm not sure.
So she takes one and then replaces it.
So would it be So would it be 7 and 4 again?
So those are the same. And then part B, how many ways are there of picking 2 yellow balls?
3 ways.
And what are they?
First choice first choice 1 and second choice 2 times. Is that
So if you had these and you called them like yellow 1, yellow 2, yellow 3, and so on.
Yeah.
How many different combinations are there of taking 2 of them?
So there'd be 2 yellows and the rest would be red. Wouldn't it?
Right, but how many combinations are there? So if you have a combination lock and it has 2 dials and 7 numbers, how many combinations are
there? And this is for 2 yellow balls.
Yeah.
So it'd be 2.
No. You see, so you have a combination code.
Yeah.
On a padlock. And the possible numbers in it. So we'll start with 1, 1. The possible numbers are 1 to 7. What type? How many possible combinations are there in total?
So there's.
So you could have 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4.
Okay, so I'm really not sure. I'm lost.
It would just be like a rectangle where it's like base times height.
So it'd be 7 times 7.
Yeah.
So 49.
Yeah, and so in total there's 49 combinations that you could do, and same with this one. So there's 7 yellows, and so you could get, pick one of the 7 possibilities. Then the next one is put it back, pick another of the 7 possibilities, and so in total 49. And so that just shows you that with a tree diagram you multiply across.
So B's 49.
Yeah.
Okay.
So when you're looking at a tree diagram, if you're going across, multiply. I'm not doing any more of these ones. They're weird. Okay, this one. Okay, how do we do this?
So are we doing 9A?
Yeah.
Okay. What's the probability stops at the first set? Is when it says the first set, does you mean the first set of lights?
Mm-hmm.
Okay, so would it be 1/3?
Let's see. Yeah.
What's the probability she stops at both sets? Is it 2/3?
That would be if you were adding across.
Oh, multiply. Okay, so it'd be 1/9.
Yeah. So it's like the 7 times 7, a third times a third.
Okay. That actually doesn't stop at either set. So it'd be 2/9.
2.
Wait. Oh, sorry. I was looking at stop, then not stop. At the top. So it'd be 4/9.
4/9. So what's the probability she stopped at just one set of lights?
What's the problem is she gets just one. Is it so not stopped or stop? Oh, she gets stopped. At just one set. So it'd be 1/3.
So you might think that, but she has to go through 2 lights. The probability she stops at no lights is 4/9. That's one we just saw. Probability she stops at 2 lights is 1/9. And so the only other possibility is she stops at 1 light. What fraction is left over?
3/9.
And what would they add up to?
What would they add up to? Oh, sorry. 5/9.
And so how many ninths more do you need to add up to 1?
One more. Oh, sorry. From 5.
Yeah.
Oh, 5. Sorry. To 9. 4.
Yeah. And so that's 4/9. So strangely they're the same. So the way you could do this one is you could do the probability that they stop and then not stop. So that's 1/3 times 2/3.
Okay.
So there and there. But then you have the other possibility. They could not stop at the first one and then stop at the second. That's still 1 light, 1 light. So that's 2/3 times 1/3. So it's the same thing. And so you're just gonna double it. 2/9, 2/9, and you add the two together and you get 4/9.
Okay.
Or you could just double it. So any questions there?
No.
And the other thing is, if you have all possibilities, you can just do 1 minus those to get the only thing that's remaining, which you use later. All right, how about this one?
So would the probability of the bus being on time be 3/4?
Yeah.
Okay. And then for it being not late, but on the second day it'd be late and not late. Would one of them be 1/3 and one be 2/4? No, sorry, 1/4 and 2/4 for being not late, but on the second day it's late or not late.
I think you're thinking of something. You're thinking of conditional probability. The probability doesn't change for the bus.
Oh, so would the second day be 1/4 and 3/4 again?
Yeah. Okay. So what is part A?
Work out the probability that the bus is on time. 3/4.
Yeah. B. Sorry,
Is it?
we did B. C.
Work out the probability that the bus is on time 2 days running. Would that be one quarter?
That would be if it's late.
Oh, 3/4. Sorry.
For 2 days.
Oh, so would you times them together?
Yeah.
Oh, so it'd be 9 over 16.
Yeah. And D.
Work out the probability that the bus is late on the first day and on time on the second day. Late on the first day is 1/4, and you got to times that by on time. So it'd be 1/4 times 3/4. So that would be 3 over 16.
That's it. Hold on. Okay. Okay, here. No, that's not anything more difficult. That's that one. I think you're fine there. That one, I think you're gonna be fine for this one. This one is decimals, so I'll do this one.
Okay. Would Wendy doesn't 0.6?
Mm-hmm.
Okay. And going back to the coconut shy, would the probability of Wendy does not win would be 0.1?
No.
Oh, would it be I'm not sure. Would it be 0.4?
No. What did these two add up to?
10. No, yeah, 1. Sorry, 1. Sorry. Oh, so would it be 0.7?
Yeah.
Okay. So the probability she wins at Hoopla. Oh no. I'm not sure. Would it be 0.4 and 0.6 to get for the coconut shy when Wendy does not win but wins on coconut shy?
So this one is Hoopla.
Yeah.
This one is coconut shy.
Oh, so would they be the same? So it'd be 0.3 and 0.7?
Yeah.
Okay.
Okay. So then this one down here.
Work out the probability that Wendy wins at Hoopla and also wins. So wins at Hoopla and also wins. So it'd be 0.4. Would you be timesing them again? So 0.4 times 0.3?
Mm-hmm.
Oh, so that would be 1.2.
You can't get a probability more than 1.
Oh, so it'd be would it be 0.12?
Yeah. So 1 digit after decimal, 1 digit after decimal, and so 2 digits after decimal in the answer.
Okay.
I think you're good there. Okay, so this is the thing you were thinking of. Yeah, let's do this one.
Okay. Would A be 4 over 10?
Probability of pink 4 out of 10, yeah.
How picks a sweet at random. What is the probability? So would the next one be 6? No. Would be well, actually, yeah. Would it be 6 over 10?
So it's just saying how many sweets are left in the bag.
Oh. So have they taken out? She's taken out the pink sweets. So that just leaves.
She took out 1 pink sweet.
9 over 10.
How many sweets are left in the bag?
9.
Yep.
Oh yeah, it's not asking for probability. It's total. How many peak sweets? Is it 3?
Yeah.
The probability of pink, will that be 3/9?
Yeah.
And 6/9.
Yeah. That's it. And so they were just kind of walking you through it. That one I'm leaving. Okay, so let's do this one.
There's another box of chocolates because ain't Reese's. So would the second choice be 2 and 3?
Why would it be 3?
Because it would stay the same because it's at random.
This is the hard sweets.
Oh, is it 5?
Mm-hmm.
Okay, and then so it'd be 2 and 5 again.
This is when they take a hard sweet.
So would it be 3 soft sweets and 5 hard sweets? No, 4. Sorry.
Well done. Yeah. So for this one here, they take a soft sweet. So soft sweet goes down by 1. Other stays the same. This is where they take a hard sweet. So soft sweets stay the same. Hard goes down by 1. Yeah. So this takes a little bit of practice. Okay. How about this one?
So contains 7 yellow and 3 green. So the first choice of 7 yellow balls would be next to the first choice, wouldn't it?
Mm-hmm.
And then 3 there. So with the second choice, would it be 6 and 3?
Mm-hmm.
And then would the next one be 7 and 2?
Well, how many ways are there of choosing 2 yellows?
So you've got 10 in total. Am I doing the right way? So we got 10 in total.
No. So how many different ways?
So it'd be would it be 7 times 6?
Yeah.
So that would be 42.
Well done. So if they'd put it back, it would be 7 times 7, but they didn't, and so it's 7 times only 6.
Okay.
Okay, let's see this one. So we're gonna probably pick. No, I'm not doing that. Yeah, this one.
Use the tree diagram to find out the probability that Larry eats 2 toffees. So would it be 2? So 2 toffees. So that would be. So would you do 7 times 7/10 times 6 ninths?
10 times 6 over 9. Yeah.
So that would be 42 over 90.
Okay. B.
One type of sweet. So would that be? Could you do 3/10 times 7 ninths?
Yeah.
So that would be 21 over 90.
So that's the probability that you get a jelly and then a toffee.
Oh yeah, so it'd be this. Yeah, I thought on each type of sweet. So would it be? Could you just to just get one type of sweet, such as the jellies? Would you just do 3/10 times 2 ninths?
No, you're correct. So one of each type of sweet.
Okay.
So that's a jelly and a toffee. That's one of each. You do have more than just 21 chances, though.
Do you have to do 7/10 times? Oh no, yes, 7/10 times 3 ninths.
That's right.
Okay. So that would be.
Mm-hmm.
Yeah, that'd be 21 over 90 again.
Yeah. So basically, you've got double your chances, and so total probability for that.
42 over 90.
Yeah, and these questions are just awful. I took these out of a new book. That is just, why would they have the same probability twice? You probably think, oh, these have to be the same. They don't.
Yeah.
And I saw a question earlier where it was like 4 over 9, and then it was 1 over 9, and 4 over 9 again. Like, why are they doing this?
Oh.
It just kind of gives the impression like, oh, those two will always be the same, but they're almost never the same.
Mm.
Anyway, this one.
Okay. So there are.
No, I'm gonna skip this. I think.
Oh, okay.
I think I'll be fine there. This one. Yeah, let's do this one.
So for the second set of stopping, would it be 0.4 to not stop on the second set?
Yeah.
And then for the first set of not stopping, would that be 0.6?
Yeah.
So stopping and not stop. So first set stopping. No, sorry. First set not stopping, but to the second set to stop, would that be 0.6 as well?
The second set has its own settings.
Oh, so if he stops at the first set, the probability he stops at will be 0.25. So if he stops at the second set, it'll be 0.25. So would the next one be 0.35?
Why is that?
Because it needs to add up to. Oh no, sorry. It's 0.75 because it needs to equal to whole.
Yep.
So the probability that Mr. Brown stops at just one set of traffic lights. So you could do 0.4 times not stopping. So it would be 0.4 times 0.4.
Yeah.
And that would be 0.16.
Yeah. So that's the probability he stops and then doesn't stop.
Yeah.
So stops at the first, doesn't stop at the second. Is there any other way he could stop at just one set of lights?
Could you do, he doesn't stop at the first set but stops at the second set, so that'd be 0.2 times 0.25.
Yeah.
No, sorry, 0.6 times 0.25.
Yeah.
And that would be 0.15. My calculator.
Oh, trust your calculator. Yeah, 0.150, yeah. Is that it?
Could you also do where he just stops on one set of lights? I don't think so.
So there's two possibilities. One is he stops at the first only. The second is he stops at the second only. So one is 0.16, one is 0.15.
Okay.
And then we need the overall probability that he stops at one set of lights.
So could you say...
You just add these two together.
Oh, so 0.16 at 0.15 is 0.31?
Yeah. So basically, the probability he stops at the first and not the second is 0.16. But then the probability increases because he could also not stop at first but get stopped at the second. And so you increase it by 0.15. So you add the two together.
Okay.
Any questions there?
No.
Okay. Exam style question. Yeah, let's do this one. It's a good one.
Okay. So for the first sock, would the grey be 3 over 10?
Yeah.
So would, for the second sock, would the brown be 6 over 10 for the second sock? Out of, so he picks a brown, then for the second sock he gets a brown again, so would that be 6 over 10?
It was out of 10.
Oh, sorry, 6 over 9, because I've taken it.
Yeah.
And then would it be 3 over 9?
Yeah.
And then would the next one here, for if they pick a grey and then a grey again, would that be 2 over 9? Oh, sorry.
Sure.
Yeah, 2 over 9, and then the the brown would be 6 over 9.
Yeah. And that's A, and then B.
So do you have to do 7 over 10 times 6 over 9,
Mm-hmm.
and I'll give you 42 over 90.
Uh-huh.
And then you do 3/10 times 2/9,
Yeah.
which is 6 over 90.
Mm-hmm.
And then do you add the two probabilities together, so giving you 48 over 90?
Yeah. Well done. Any questions there?
No.
So 90. Okay, got it. This one is similar. I'm gonna guess that you're gonna be fine for that.
Okay.
You did that last one very well. Okay, this time there's no tree diagram. It'd probably be easier to do it without a tree diagram. How do we do this?
Okay. So it has 5 red pens, 3 blue pens, and 2 green pens. Gary takes out a random pen from the box and gives the pen to his friend. Okay. So. So he would always be taking away one, because he's given one to his friend.
Mm-hmm.
So would the probabilities be like, for red pens giving it to his friend, 4 over 5, blue pens be 2 over 3, and then green pens be 1 over 2?
I don't know where you're getting your denominators or numerators from. What's probability he takes a red pen first?
So would that be so if he takes 1 pen, would that be 4 over 10?
There's more than
5 over 10.
So that's 5 over 10. And then probability he takes another red?
Would it be 4 over? Would that be 4 over 10? No, 4 over 9. Sorry.
Yeah. And so probability he takes 2 reds?
3 over 8.
Just overall probability he's taken a red and a red.
So that would be 20 over 90. Am I supposed to times them?
Yep, 20 over 90. Okay, and then do the same for 2 blues, do the same for 2 greens, and then get overall probability. I'm just gonna run to the toilet. I'll just be a sec.
Okay, so the next one will be 3 over 10, and then so the next one will be 3 over 10, and then times 2 over 9, and then 2 over 10, 1 over 9, and I'll give you 2 over 90, 6 over 90, add 20 over 90, 6 over 90, add 2 over 90, so that would be 30 over 90. Okay, that's my answer. Oh.
How'd you get on there?
I did for the blue pens, I did 3/10 times 2/9
Mm-hmm.
and got 6/90.
Mm-hmm.
And then for the green pens, I did 2/10 times 1/9, and that gave me 2/90.
Mm-hmm.
And then I added them together, so it'd be 20/60 adds 6/90 add 2/90 gives me 30/90.
28/90, I believe.
Yeah, sorry, 28/90. Sorry.
That's it. Any questions there?
No.
Okay, so sometimes it's easier to do it without a tree diagram.
Yeah.
So as a 4 marker, hold on a sec. This one, that's the probability that they're the same color. How would you find the probability of not the same color?
So, so would it be? I'm not sure.
What if it was a tree diagram?
Yeah.
And that was same, and that was not same.
Okay. So.
And that was 28/90.
So the next two. So it'd be 62/90.
Yeah, and so the way you do that is 1 minus the probability that they are the same.
Okay.
Yeah, so 1 minus probability they are the same, which is 1 minus 28/90, which is 62/90. Yeah, any questions about that one?
No.
So this one you have to find the probability of getting not the same type. So how would you go about that?
So could you work out what the same type and then do the thing we did at the end, or will that be too long?
No,
to do?
believe it or not, that's the quickest way.
Okay. So
I think you'd be okay with it.
yeah, I think it'll be okay.
It's just very similar. So yes, they're doing that 1 minus probability same. It's because to do it the other way, that they're not the same, instead of 3 possibilities, there's a total of 6. And so you'd have to remember to double it at the end or something. Okay, how do we do this one? Hang on, skip part A, part B.
Calculate the probability that the number on the second tile Jim takes is greater than the number on the first tile. Okay. So would you'd have to do you'd have to find the same. I'm not sure. Would you have to find the same, like what they are the same, and then add them all together?
So this one is asking. It says the probability the second tile is bigger than the first. So it might help to kind of write down the possibilities.
Okay. So there'd be. I'm not sure how to write it. Would you just be 1/1? Sorry, 1, 2, 3. 1/7 for.
So what are the possibilities where the second tile is bigger than the first?
Wait. I'm really not sure. I'm not, because I'm not sure what the first tile will be. Because I'm thinking of when you to find out what the first tile will be.
Okay, let's say you take a 1 first.
Okay, so it'd be more than 1, so that would be 5 more.
Wow. Take a 1. Okay, so he takes a random tile. He takes a second tile. Calculate the probability that the number on the second tile is bigger than the number on the first tile.
Would it be?
So the number on the first tile was a 1. What's the number on the second tile?
I'm lost. I'm not sure.
It could be 2, because 2 is bigger than 1.
Yeah. Oh, okay.
Any other possible way that you can get the first tile smaller than the second, or second tile smaller than the first?
Could the next one be 3?
And what was the first one?
Sorry, say that again.
And so what's the first tile? What's the second tile?
And the first tile would be 1.
And
And then the
second
second tile would be 3.
That's it. Any other possible combinations?
Could it be 2? The first tile would be 2, and then the second tile would be 3.
That's it. Are there any other combinations, or is that it?
I think that's it.
That's it.
Yeah. It is.
Okay. Probability of a 1 then a 2.
A 1 then a 2. So the probability of it being a 1 is 2 over 7.
Yeah.
And then the probability of it being a 2 is 3 over 7.
Not over 7 anymore.
Oh, sorry, 3 over 5.
Not over 5. That'd be if you took 2 tiles.
Oh, so we're taking 1 tile, so it'd be 3 over 6.
Yeah.
So you times those together to get 6 over 42.
Yeah. Go on.
And then it'd be 2 over 7.
Yeah.
Times 2 over 6.
Well done.
And then that would be 4 over 42.
Yeah.
And then for the next one, it'd be probability of it being a 2 is 3 over 7. And then it being a 3 would be 2 over 6.
That's it.
That would be 6 over 42.
Yeah.
Add them all together, and that gives you 16 over 42.
Well done. So that's the probability that the second is greater than the first. And how would you find the probability that the second is not greater than the first?
You would do 1, take away the 16 over 42, and that would be
yeah, whatever that would be. 42.
Yeah,
42 minus 16.
26.
Yeah, 26. That's it. 26 over 42. Okay. Any questions about that one?
No.
Okay. So this one's very similar. So that's it. That's probability anyway. So probability, x a half or tick.
I say 3/4.
Okay. So okay. How do we do these?
So the value of 10 cubed, that would be 10 times 10 times 10.
Mm-hmm.
So that would be 1,000.
Yeah. 1 of 3 zeros. This one.
And then this would be 10 times 10 times 10 times 10 is 5 times. So that would be 10,000.
Yeah, 1 with 5 zeros. Whatever it is. 1, 2, 3, 4, 5. I think it's 100,000.
100,000.
This one.
So that'd be 5 times 100. So that'd be 500.
Yeah, 5 2 zeros.
And that would be 3 times 10,000. So that would be 3,000. No, 30,000. Sorry.
Yeah, I'm never sure. I just do 1, 2, 3, 4. Yep. Okay. So standard form always looks something like this. The first number has to be between 1 and 10. That's the tricky part.
Okay.
Times in the middle, and then 10 to the power of something. So first number has to be between 1 and 10.
Okay.
Okay, standard form or not?
Standard form. Not standard form. Not standard form. Standard form. Standard form. Not standard form. Not standard form. Standard form. And not standard form.
Yeah. Okay, these two.
So AI would be 14 times 1,000, so that would be 14,000.
Okay.
No, yeah, 14,000. And then 1.4 times 1,000, that would be 1,400.
Mm-hmm. Where did the extra 0 go?
To go on the other side of the decimal.
Yeah. Okay, next two.
So that would be 231 with 5 zeros.
Yeah.
And then the next one would be that would be 231, but with 4 zeros. So that would be
Why only 4?
because doesn't the other 0 go on the other side of the decimal?
So there's two numbers. So what is this times 10?
23.1.
And so you'd have to times it by 10 again to make it a whole number.
Okay, so that'd be times 100.
Yeah.
So
So how many 10s are left over?
so we've used 2 10s, haven't we? So that'd be 3 left over.
So that is what is necessary to make it a whole number. And so then what is the answer?
So that would be 2,310.
Let's say 2, 3, 1. How many zeros?
3.
Yeah. Where did the 2 extra zeros go?
Are they on the other side of the decimal?
Because they got used up. So what's the connection between these two?
So how many numbers are behind the decimal are the zeros that are on the other side of the decimal point because they're used to get the whole number?
Yeah, so basically when you have one decimal after you take away one of the zeros, when you've got 2 decimals after you take away 2 of the zeros, and so on.
Yep.
And that's how it works. That's kind of a quicker way of doing it. Okay, let's try this one down here as an ordinary number, big one.
Which one? 4.9.
Yeah.
So would that be 4,100? No, sorry, 49,000.
Yeah, I know, 3 zeros. This one?
What? 8 point. Oh no, sorry, 3.8. So would that be 38,000?
I don't know. 3, 8, and how many zeros?
4 zeros.
Yeah. And let's say the last one.
The last one, that would be 671 with 4 zeros.
Well done. 3, 4. I don't know what these numbers are. So big. Okay. Standard form into ordinary numbers.
Tick.
First one.
Would that be 10 to the power of 5?
Yeah, fine. This as an index number, as an ordinary number, I think it'll be fine. Okay, how about this one?
So would that be so the instant? So we're doing. Oh, is it the 5 times 1,000 one we're doing?
Yeah. So converted it back into standard form.
So would that be 0.5 times 10 to the power of 4?
And why did you make a 0.5?
Because could it just be 5?
Yeah, 0.5 would be too small.
Okay, so it'd be 5 times 10 to the power of 4. No, 3. Sorry.
Yeah, this one.
So would that be 9 times 10 to the power of 4?
Yep. These two.
What, 2,000 and 2,100?
Mm-hmm.
So that would be 2 times 10 to the power of 3.
Mm-hmm.
And would the next one be 2.1 times 10 to the power of 2?
So if you did to the 2, one of those zeros would get taken up.
Oh, it'd be 3.
Yep. This one.
Would that be 5 times 10 to the power of 4?
Mm-hmm.
And would the next one be 5.27 times 10 to the power of 4?
Yep. So you got 1, 2, 3, 4. Okay, let's say this first big one.
Would that be 1.25 times 10 to the power of 5?
10 to the 1, 2, 3, 4, 5. Yep. Next one.
Would this one be 6.08
Mm-hmm.
times 10 to the power of 6?
So that would put the decimal there.
Oh, sorry, 7.
Yeah. So 7. Let's try this one here.
Okay. So would that be 9.56 times 10 to the power of 7?
Yeah, I think those are okay. Ordinary numbers back into standard form.
Tick.
Leave that. Skipping all this. Skipping all this. Skipping all of this. How do we do this?
Standard form calculations. So would you convert it first? So it'd be 9 times.
So no, sorry, go on.
I was going to say, could you mix the two indices together? So it'd be 9 times 2 times 10 to the power of 6.
Yeah. So you could just rearrange it. That's right. Okay.
And could you then do So could you do convert it then to do 18 times 10 over 6?
And what if they said give your answer in standard form?
Would you do 1.8 times 10 to the power of 7?
Yes, that's it. Okay. Let's do the. You got me fine for those.
Okay.
Let's just do C.
Okay. So I'm assuming you'll have to use BidMass because it's got brackets in it. So that would be it'd be 21.
No. So that'd be going the other way. The brackets. Who knows why they're there? Everything is times each other, and so the brackets are unnecessary.
Okay.
So you could ignore them.
Okay. With 6 times 10 to the power of minus 5, that's going downwards. So that'd be point something.
Irrelevant.
Oh.
So 2 points. So you don't need any brackets.
So would it be would you be timesing 10? You'd be timesing by 10 to the power of 3.
Yeah.
So you would do would you quickly do 2.1 times 6?
Yeah.
So 2.1 times 6 is 12.6.
And give your answer in standard form.
So would that be 1.26 times 10 to the power of 4?
Yes, that's it. Yeah, so those ones, sometimes they put them in brackets, sometimes they don't. Just ignore the brackets, because if everything is, plus, if everything is times, you don't need to. It doesn't matter what order you do them in. So here they put them in brackets. Doesn't matter. Just ignore the brackets and do it as normal. No, normal number times normal number square times square root. So these are calculator questions, but I think you're okay to put this into your calculator.
Okay, so
let's just do the very last one. Yeah, let's just do this one.
So it would be so what I would do first is put the two tens together, so it'd be 10 to the power of 9.
No, it's a calculator question. So I would just put the whole thing into my calculator exactly as they've written it.
Okay.
Let's try that. Technically, you don't need the brackets, but I'm just gonna literally do it exactly.
Okay. 97.
No. That was my other one.
Oh, 1.7. Sorry, 1.17 times 10 to the power 10.
Yep, there you go. So I hopefully times 10 to the 10. So hopefully gave us that. Multiply.
I say a tick.
All right. And how would you divide standard form numbers?
So with would you be taking them away? So no, sorry. Is this calculator or non-calculator?
Non-calculator.
Okay. So would you work out the numbers first? So 4.2 times 10 to the power 8 is 42 with 7 zeros.
So you never do that. The purpose of standard form is so you can do these numbers. Otherwise, you'd have like, insane type of stuff. I don't even know. 1, 2, 3, 4. So you leave them as they are.
I'm not sure.
What might be easier is, what would that be if it was a whole number?
42.
And so what would be on the top then?
It'd be 42 times 10 to the power of 9.
You had to use one of your tens.
Oh, sorry, 7 to the power of 7.
Okay. 42 divided by 7.
6.
And then these two?
Times 10 to the power of 3.
Yep. That's it. So same thing. Let's do the second one. And making them... Oh, there's just no easy one, is there? Let's see. Oh, it's very common that they do that. Well, it's not easy. 3.5. Let's do the second one here.
Okay. I'm gonna quickly write it out real quick. So we probably want to get them to whole numbers. So instead it'd be 23 times 10 to the power of 11 divided by 46 times 10 to the power of 2. So 23 divided by 46 is 2.
That would be 46 divided by 23. 23 over 46.
Would it be 0.5?
Yeah. And then the other one?
It'd be times 10 to the power of 9.
Yeah. And now put that into a standard form. Oh, just a second.
Five.
So what's the answer there?
Will that be 5 with 8 zeros?
So 5 times 10 to the 8?
Yeah.
Give your answer in standard form, so they don't want it that long way. Yeah. 5 times 10 to the 8. These are calculator. You just put them in your calculator. They're easy enough. So standard form in general, x a half or a tick.
Oh, I say tick.
So we didn't get onto the small standard form, but we got most of it done.
Okay.
How was that for you, Noah?
Oh yeah, that was good. Thank you.
Anything in particular you want to do next time, or should I pick?
You can pick.
Okay, and it might be, it'll be something like that.
Yeah.
Any questions for you in general?
No.
Okay. Well done, Noah. You did great. I look forward to